Okay, perfect, ready. So today, volumetric rendering. As I said, it's not complicated. It's complicated to do it fast. It's very easy to do it slow, and we're going to do it slow. Like it's not going to be super performant, but it's what we have. So that's it. Also, I mean, when you see this kind of volumetric, it looks super nice, but I cannot tell you that it's going to look so nice in our engine. It's going to look way simpler. But at least it's a start, and there's a lot of room on the algorithms explained here on the slides to improve. I mean, once you understand it, you see that it's very simple. I mean, it's not something very GPU specific. It's more like physics specific. I mean, you're going to read values and use those values to define some sort of color that is going to be the color of the air, and then you paint it on top of the scene, and that's it. The more complex you do this part, the part where you have the equation, the more interesting it's going to look, and you can play around with it. Even though I'm going to explain a very simple solution, I expect that you, I don't know, try to play around with different parameters and approaches, and see what can you come up with. And even if it's not super performant, it's okay, because we can render to a low resolution texture, and that will solve many problems. Okay, so without further ado, this is the latest version of the code that I show you. I think this is the latest time I implement here something, was probably for the this is a IO, and there is also the Pro for irradiance. Okay, but I'm not going to use anything. I'm not going to use the SSAO or the props. I'm just going to use the regular rendering function that I have here in my engine. So not much to say here. So this algorithm doesn't require a lot of information about the scene. It only requires the depth buffer, because we're going to do ray marching. And remember, ray marching, the idea of ray marching is super simple. Is that for every pixel of the screen, like every single pixel of the screen, we're going to find the ray that on that pixel goes from the camera through that pixel forward. And depending on what we want to render, I mean, if it's going to be some sort of volumetric that affects the whole scene, something like the whole room is full of smoke, then we will apply this, we will do ray marching for every pixel starting from the near plane forward. But also, if we are rendering some sort of kind of volumetric thing that is more like an area, then this is something that some games do, where they have like a volume, like a box. They define the area where they want to have the smoke. Then you will render an object in the scene, and you apply this volumetric shader to the pixels of the surface. So you will do it from here forward. As I said, in this case, we want to apply the volumetric for the whole scene. So I'm not going to render a cube and apply the volumetric thing, which makes sense in some situations, but I'm not going to do it. I'm going to do a full screen quad, which is the simplest one, and I'm going to do a ray marching. And remember the concept of ray marching, and we have a ray, and we're going to keep doing small steps. So we're going to do a step here, and then another step, another step, another step. And with all these steps, we're going to compute the final color. This is the color we're going to draw on this pixel, okay? So this is why it's marching, because you're doing step by step. It's like marching, walking. And always the question is how many steps, what's the distance between every step. That's something you have to play. Okay, I mean, there's not a perfect solution, and everybody tries to come up with different approaches. And the better you use the steps and the distance and all those kind of things, the better it's going to look at the end when you render. Okay, so without further ado, what we want to compute now is for every single step, what we really need is to know how much light it is. But if we assume that every single point on our space has the same density, and every single point on our space has the same color, this is silly, because we are going to do ray marching for values that are constant. And it's always going to give you the same value. This could be easily integrated with a simple function. But we need to be sure that in our approach, when we are stepping, these values can change. What can change? We could change the density if we have some sort of, I don't know, noise function to construct some kind of noise that has like a Perlin noise that gives some areas more density and others less density. You want to play around with that. That's possible. It's easy to do if you want to play with that. I'm not going to do it in the video today. But what is important is we want to be sure that every single point doesn't have the same illumination. We want different points to have different illumination. So if different points has different illumination, that means that we have, for every single step we're going to do through this ray marching, we have to compute here illumination. And this illumination has to be affected by, first, by the position of the light, and secondly, if it's inside shadow or not. Okay, because I don't have too much time today to do this, I'm not going to compute the ray marching, the illumination for every single light. I'm going to focus only on the directional light, which is the most important one. But if you want to play around with the idea of using the same approach for different lights, like the spotlight or the point lights, it's okay, you can do it. It's the same algorithm. So you can play around with that. You can have like a shader that says maximum 2 or 3 or 4 lights. It's not a good idea to have ray marching over all the lights of the scene, because that would be very complex. And usually when you do ray marching, it's because you are in some sort of day scene where there's a lot of fog. And in those situations, they only have one light, which is the sun, usually. Okay, so here, remember, we have in this scene, obviously, we have the moonlight, and this is the light of the from the sky, and here is the light. Which, by the way, I don't see the shadow map. I don't have the shadow map? Wait a second, because if I don't have the shadow map, well, I can do it for the spotlight, which I have the shadow map of the spotlight, but I don't like that. 1 second. This has shadows. Well, if you compute the light and you do not update it, the shadow stays there, because I'm not controlling every time. But I don't know if I put it the renderer for the directional light. Shadow maps. Generate the shadow maps here. I only did it for the spotlights. Okay, it's different from, it's equal to point light. Sorry, I forgot to put for the other ones. So if it's different, I mean, point lights don't have shadow maps. For the other ones, remember that if camera, if light type equal to a light type directional, we do it with the camera set orthographic, otherwise we do it like this. Okay, so camera set orthographic, and I don't want to have to play around with many values. I don't know if we have here the area. Yeah, I have the area. Okay, so minus area. The next is the right, is light area. The bottom is minus area. The right is area, and for close I'm going to go with 0.1, and here for max is going to be max distance. Yep. Okay, perfect. So now we have a camera and we render, and I think the rest will be the same, because we are going to bind it, we're going to render the frame, we're going to bind it, we're going to store the view projection matrix, everything exactly the same. And when we go to the shader, which is not open, I'm going to bring the shader. 1 second, I'm searching on the other window. That shader here. Bloop. Okay, so the one I was doing the other day, which is this one over here. When I compute the shadows here, if it's directional, but if it's spotlight, I'm computing the spot cone, and the shadow factor is here. So if it has a shadow, it's going to compute it. And the function text shadow works the same for directional than for the other one. So as far as I know, it should look the same, but the shadow factor should not be multiplied. Aha, this will be missing. I have to put also this one here. Okay, so let's see if I have shadow maps now for the directional lights too. And if not, it's okay. I can go with the spotlight, but I want to do it with the directional because it looks more beautiful. It's more realistic, at least, because it's usually when there's fog, is the directional light the one that has more. So we don't have light shadow maps here. Although I don't know if I can. Did it put an option to see the shadow maps when I was show shadow maps? Yeah, the shadow map is here. Although the near and the far planes seem not to be working very well. 1 second, because I think that I didn't put the parameters right for this on the. So I'm going to go with, I don't know, 4,000, and the near distance. There is a near distance parameter. Oh, I didn't know that. So I should put it that one also. So when light is directional, here should be light near distance. Okay, so now it has to show the light map. And no, we don't have it. Although we have the shadow map. Show shadow maps. It is here. It doesn't look very nice for the moonlight. I don't know if anybody remembers that you have to tune the parameters probably right. And here, probably I'm not uploading the shadow map. Pretty sure I'm not uploading it by some strange reason. Or maybe the shadow map is seen from below, which is something that really happens sometimes. So I think I'm rendering from below, maybe the shadow map. So it's this front. I think there was an error that it was -1 if it's one or the other one. I'm going to try it. If it doesn't work, doesn't work. And if anybody remembers I had to change anything, let me know, because I totally forgot about this. And I wanted to check if I'm sending the shadow map from the function to render. Anyway, if it doesn't work, I go with the spotlight. And if I have some time left later, I will put the other one. I want to see if how does the shadow map looks now. Yeah, I'm not sure this is right. Anyway, let's go with the spotlight. If I have some time left later, I will try to fix it. In the slides, I think there was this code on the camera. Well, the half area, yeah, I mean, I can use the half area, but yeah, it's the same. I mean, I'm making it bigger, but it should be the same. Thank you, David. But I think, I mean, it's not going to be a problem. Like using area or divided by 2 and divided by 2 in all this is going to be the same. Just it will have less resolution. But yeah, I'm going to put it just in case I forget it later, but it's not going to change the problem. Okay. I think that the problem comes when I upload the texture to the shader, that I'm forgetting to upload it probably. 1 second. When I do the render material forward, this one. Yes, this is a material forward. Here, when I upload the shadow map, which is around here, light to shader. Maybe it's this one. No, I upload. If it has shadow map, if it's a spot, no, I upload the cone, but this is right. It's shadow map. Now I am doing everything right. So if it doesn't work, doesn't work. Okay, then let's do it with the shadow map, and if I have some time, I will try to fix this later. Okay, so how do we approach the problem with the volumetric? First, we need the whole scene rendered to apply the volumetric, or at least we need the depth buffer, because in this example, do I have the deferred renderer? No, yeah, I have a deferred. I'm going to do it for deferred, mostly because it's easy, because you already have the depth buffer and you can put the computation wherever you want to. It can be done in forward, and the other day when I will show you my example from my code, it was using the forward render, the one on the web. But here I want to use it here, like first I'm going to compute the G buffers, so I have all the information about the scene, and maybe after I have computed the SSA FBO, I can compute here the volume. Okay, so let's put it here. I'm going to need an FBO to do this, so as always, let's create a new FBO. Oops. Okay, and then when we are going to compute it, like here, these kind of things, always put them in functions. Don't be so silly to put them here. Okay, so I'm going to need to create the buffer for this one, and yeah, I'm going to do the same I do with the other ones, which is put it here. And this also, I mean, these kind of algorithms like SSA, YAO, or volumetric, you always could compute them during the moment when you need them. Like for instance, we are using the SSA YAO, when we render the ferret global that takes all the global illumination, I can compute the SSAO directly on that shader, the global one. But the good thing about separating into a special buffer, like special texture, as we're doing here and here, is that you can control the size of this texture. Because if you compute it in the final moment where you're using it, that means that it has to be at the same resolution as the final image. But here you can use it at different resolution, and that's always good. And about the volumetric, I can say if I want only one channel, it's going to be better than if I need more channels. But if we have color, if the volumetric has color, then it would make more sense to use RGB. So for now, I'm going to go with RGB because maybe, I don't know, in the future I wanted to have color. But if you put luminance, it's going to be a little bit faster. Remember, the less memory you use, the faster it goes. And about if I need to be one single byte per component or I need more bytes, well, I can assume that the amount of illumination on the volumetric is going to be very low. It's going to be probably like, I don't know, I mean, from 0 to 1. I don't expect to have some areas of my cloud volumetric render to be super shiny. So I guess with Infinity is way better. Okay, if you are expecting to have areas of the volumetric rendering very, very bright, then I would recommend you to go with half float. Okay, imagine that you have something like this. Let me show you a photo, something like this. 1 second, I'm searching photo here. So this is haze. They call it this when this area very I think with a lot of volumetric thing. And if you search for haze at night, you see that when you have haze and there's lights around, there could be spots that are super bright and they look super beautiful. Okay, so I mean, it's not so crazy to think that maybe makes sense that our volumetric is not one segment byte, it's more. But for now, just go with something simple, and you can always tweak it. And I want it to be fast because we're going to have to do a lot of computations. Think that making this float is not going to make it much slower because this at the end is where it's going to store the data. And what makes it slow things is when you have to read a lot of data from the shader. On the shader, we're going to read from the depth buffer, and so that means that changing this is not going to affect a lot the time it takes to render. And the same with you put here luminance probably is going to maybe if you do some sort of benchmarking, you won't see much difference. So there's no need to do this. Okay, so after SSAO, let's go with our here, and we're going to bind and bind, and boom. Okay, so what are we going to render? We're going to render a plane. So we're going to copy a lot of things from our SSAO. We don't want depth test. I'm going to disable blending for now. In the future, I will enable blending. I'm not going to need the normal of every pixel because I only care about the distance of every point to the screen. So no need. The depth, yes, obviously, we need the depth a lot. We don't need points on this. The view projection, no, I don't need this, nor this. The camera position, yeah, maybe it could be useful. But what is also missing here is information about the light. And we need to have one light to compute this. Which light? Well, depends on when you want to compute the volumetric, you need to specify which light you want to apply, or you can upload all of them somehow and try to read them. But here, because we need to pass also the shadow map and all those things, we better have a clean code here. So what I'm going to do, and this is one of the reasons why having as I was saying, a shadow map atlas is better because then you can pass all the shadow maps at the same time. Now, otherwise you will have to pass every shadow as a different texture, and that could be a little more complicated. Anyway, I need here to have the information about the light that I'm going to render. And there is lights here. There's an array of all the lights. As far as I know, the first light is the light of the spotlight. So I'm going to assume that the light that I need spot is this one here. Oops. Is the lights this 0? Okay, I'm hard coding a lot here. Okay. Usually what you can do is you can iterate through all the lights, find the light that is a spot, and use it. Okay. I'm hard coding now because I want to go fast. And now we have the light. We have to upload every information that could be necessary for the algorithm to compute if there is all these haze. And for the light, I'm going to need the classical things like light position, blah, blah, blah. So let's go here. This is all the information we have for lights, okay? And let's go here where it was before, where it was. Yeah, here. Okay, so I'm going to pass the light, let's call it light, it will be easier. The light position, the light front, the color, here the type, the near distance and max distance, the shadow parameters, it like a shadow map, blah, 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 and that's it. And because it has to be a spot, I'm going to pass also the light cone. Okay. By the way, this kind of code it will be always been easier. I have it in my the other good engine, the one I'm developing parallel to this one. I have a function that is light to shader where I pass all these parameters to the shader, so I don't have to do it every time. And if I modify something, I don't want to break it. But anyway, I think I have everything: color, intensity, blah blah blah. The more it's similar here to the one we have on the other one, this will be to implement it. Okay. So we render one quad, and this quad should contain all the volumetric info, and that's it. And at the end, maybe we want to see it, because otherwise we won't see anything. So I'm going to go here at the end of everything and say something along the lines of go to the color textures, the 0, and to viewport. I want to see it, because if I'm going to code something and I cannot see it, it's going to be annoying. I'm going to need more parameters, by the way, here. I'm going to need probably density and stuff like that. So let's put some parameters about how to compute the air density. And that could be one parameter. And what else could there was air density. Yeah, I think with air density is more than enough. Because I'm not going to put the steps, because the steps are going to be hard-coded. So. And the air density, I don't know what's the best value. So let's start with something small, 001. But obviously, I'm going to put an interface to this one because I don't have any idea of what's the correct value. So at least I want to be able to play around with this one. And if we put here a slider from 0 to, I don't know, 0.1, more than 1, that would be a lot. And it's first number is the minimum, 0. The maximum 0.1, and that's it. There's no step format. Okay. No, then I'm going to make it maybe a little bit smaller. Yeah, I was expecting. Sorry, I was expecting the drag float, this one, because in this one you're gonna specify more things. You can specify the speed. I want it to be super small, like this one. The minimum 0 and the maximum 0.1. Yeah, that's one. This looks better. Okay, so now we have air density. So when we are going to go to our shader, we're going to pass this density to the rendering. These kind of parameters, by the way, we are hard coding them on the renderer, but it doesn't make any sense. These kind of parameters should be on the scene because they are part of the scene. You can have a scene that is in the, I don't know, a spooky graveyard, and you want to have a lot of density. Maybe you want another one which is in a house inside where there's no any kind of the volumetric. So I'm putting all these parameters always on the renderer because it's a fast thing, but keep in mind that these kind of things make sense to have it here as part of the information about the scene. So here we have the skybox intensity, the skybox image, the ambient light, the background. Here there should be more parameters related to the atmosphere. But for now, let's go with this. And also, when I choose this light here, which I guess is the spotlight, maybe it would be nice also that lights can have a parameter to say if they are volumetric. We can have like a boolean that say this light has volumetric or not, and using that you can compute this for that only those lights that are volumetric. Okay, cool. So I think I have everything: density, the camera, all the information, blah blah, and the information about the light. And then we render a quad, and I don't need to clear anything because I'm not using the buffer for anything. And also, yeah, when I was creating here, this is for the depth buffer, which has to be false, I guess. This is we'll use the structure. Yeah. So perfect. But not only we need the shader. Okay. So let's go. Also, maybe by the way, instead of just showing this here, Maybe I can have a flag like show volumetric or something. So at least I can control this parameter to toggle on and off. Otherwise, I won't be able to disable it. Yep. And here, I'm going to start with true because I want to be able to play with it. And here, okay. Then ready. We only need the shader. So about volumetric here, there was one shader here called volumetric that I need to create. And so the next step, so go to the shaders, and this is going to be very, very similar to the SSAO because I have to reconstruct. It's also based on a quad. So I'm going to go with this one here, and I'm going to copy it. Although I don't need all the things about the points and rotations and blah blah. So I'm going to put it here, and let's call it volumetric. Okay, so I don't need a normal number of points. I think I can let samples in my code here, so I can put samples here. No point, no radius, no front. I need all the parameters. The random one, we may need it. I'm going to leave it because we may need this one. The rotation matrix, I don't remember using a rotation matrix for this one, although maybe it makes sense. And keep in mind that I only apply this algorithm for points that have depth. Okay. I'm going to go with this one, and if it doesn't work, I will think about something. The thing is that I was thinking, like, do I need to compute the volumetric light for pixels that are the skybox? And the answer is yes. I mean, if they are on the skybox, still there could be some light passing through it. So I have to compute them. So I'm not going to control that case, and I think I have a special code for that thing. And here is where I recompute the position, blah blah, and I'm going to kill all this because it doesn't have anything to do with what I'm doing here, blah blah. And finally, I will have to put something here. We'll see what it is. Okay, so we have the skeleton. Let's go to the slides to see what we have here. So it says we need to have where the ray starts and the how much the ray is going to move forward. Okay, so here the ray will start at this ray start position. What's the ray start position? It's going to be wall position. Okay, so because that's sorry, no, the camera position. So camera position. This is where the ray will start. The right direction. I don't have the right direction here, so let's go here to the slide. Here I compute the wall position, blah, 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 and I also compute the rights here. So I'm going to go with this one. Sorry, I'm going to put it like I had it here on the slide, so there's no mistake. So I have this here. The start is camera position. The right direction is wall position, which is wall position, wall post, no. And the right start, length right there, blah, blah. So I computed here the vector that goes forward. And here, this is the maximum distance I want for my right to my right to reach. By default here, the distance of my ray is the length of right there, which by the way, I don't really computing here, so I'm going to remove it here. So here you can see this wall distance ray start with camera position, wall position. This is just the distance of the ray. So like, let me show you. Sorry, 1 second. So if I have here my camera and I'm rendering this, and this is the near plane, this here, I'm starting from here, but if you think about, that's kind of bad because I should be starting from here, not here. This is the eye. This is near of the camera, but anyway, they are going to be so close to each other that it's starting from here or starting from here, there's not much difference. So forget it. Otherwise, I will have to push here the ray to near or something like that, but I don't want to do it now, but maybe. And the other thing is that when we read the buffer, that we have out here the wall position. So when we compute this rate that goes from I to wall position and we normalize it, we have this vector that we are going to use to move forward. Okay, so this is the forward. But and here's interesting. What happens when there is nothing here? So the depth buffer is super far away, like in this ray, for instance. Imagine that there is no this doesn't exist. So something like, I don't know. Let's erase it this way. Okay, so in this case, the ray is going to be super long because it's going to go to the skybox, to the far plane. and maybe every step is going to be super big. So here what I'm doing is I'm limiting that if the ray is bigger than the distance, maximum distance is bigger than 500, just cap it to 500. So it's bigger than this number, it's going to take this as wall position. So it's going to do from here to here only. Okay, this is just to limit a little bit. Okay, so now we start in this position in ray start, and the offset we're going to move every time. The step we're going to do is determined by this scalar, which is step distance. But you can see the step distance is not defined here. So how much we want of a step distance? I don't know if I put it on the slides. Yeah, I'm not saying how much. Okay, I forgot to put it on the slides, but it's simple. The step distance is a scalar, okay? And usually we want to advance the ray length divided by the number of samples we're going to take. I say that samples are going to be 64. So let's go here and say float 64. Okay, so the number, if I know that I want to do 64 steps between here and here, I take the whole distance divided by 64, and I get how much I have to move every step. Okay, so this is a step this. And now every time we want to move forward my ray, I add ray offset to the current position, and I'm going to move forward. You can see I'm putting everything I can outside of the for loop, so that's going to speed up the computations. Okay, so here we're going to move forward, and at the end we have to render something on the output of our shader. I don't have here any value put on the output, but anyway, let's call it final color or something like that. I'm going to say, I mean, I could put here the color, but I don't know. Volumetric? Let's call it volumetric. I don't know, I was trying to find a better name. But I'm going to use one single value instead of a vector 3 because, well, it's going to be faster than using only one value than 3. Yeah, but also the light can has color. I mean, it makes sense that I'm going to use 3, and that's it. Damn it. I want to do something more special, faster, but I don't want to make it more complicated. So let's put it like this. Okay. And we're going to have, like, at the end, when you have crossed over this area, remember that what is behind the cloud, what is behind the fog, the volumetric, may be partially visible. So we need to have some sort of translucency or transparency. I don't know how I call it on the slides. Transparency. Okay, that by default is going to be 1, but the more we cross over the smoke, the less transparent. And we're going to use this value in the alpha channel. The reason why we do this is because at the end, here you can see that I'm not reading the albedo of the scene. I don't care about the albedo of the scene. What I'm going to do is at the end, I'm going to make the fog more transparent or less transparent. And because we're going to render the transparency on top of everything, that means that if it's more transparent, you will see the scene behind. Okay, so that's something like I don't have to pass here albedo and all or the final buffer when I'm computing it. Okay, cool. So I think that's it. And the last part of my shader here, I say in something like around these lines. Let's say that if in any moment transparency is smaller than 0, that means that all the cloud is covering what's behind that cloud. So it doesn't make any sense to keep going because it won't be visible at all. So in those cases, I just break the for loop and I get out and I output whatever it is. And here you can see that every time we advance this air density, which by the way, I don't know if I put the air density parameter. No, I think I didn't put it. Air density. Step this is yes, yeah. So every time we advance, we're going to subtract the density, multiply it by the amount of distance I have walked forward. And I don't know if it makes sense this not to be linear, to be more like using some sort of curve, but for now I think it's good this way. And we only need to control this color, which by the way now is black. Usually when you start with fog, you can assume that the fog has some sort of light by itself, which is all the light that it's in the cloud, like ambient light. I don't know what I put it on the slides. Maybe I start with 0 light and I'm going to keep adding here the light. Here I have a for loop for every single light of the scene, as you can see, but I'm going to only do it for one light because I only passing one light. If you want to do it for more lights, that would be way better. So evaluate contribution. I call it irradiance, but anyway, we will see. So UR density multiplied by step this, which these two multiplications, by the way, I'm going to do them a lot. So maybe I can save them outside. Something like float air step, these two things. So I can remove from here these two and remove from here these two. I'm saving one multiplication. And here light is light color, and then I have to pass all the parameters from the light. So I have here all the light position. Which ones do I need? Because this is for a spotlight, I'm going to need the light position, the light front, the color, and the near distance at the far distance, and the shadow. Yeah, I'm going to need almost every one of them. So I'm going to go for the light position and all these parameters I have here. And remember that I put here this lights thing that I can include, and it has all the code already. So maybe it makes sense to use this one. Yeah, I'm going to include lights. That way I don't have to put everything. So here I'm going to go say, hey, include lights. And that way I can test how much light contributes every time. So lights, it's here. I have the function to test the everything, and I also all the information about shadow map, blah, blah. Cool. And this is the one that was using it. And as I remember correctly, I had to do all these things. I didn't put it in a function. I should have put it in a function. I didn't do it. For now, let's copy paste this, and we will play around a little bit with this one. So inside our loop, maybe I can have a function here. Vectores compute light. I don't know. Okay, let's see. This function here, ambient light. I don't want it. Shadow factor, yeah. Shadow parameters is wall position. I need a pause because now you have to pass the position. We're going to call this function a lot of times, and every time it's going to be in a different position on the 3D space because we are going to be doing remarching. So it's good that we can test in different positions. So pause, yes. Next thing, ULA from shadow factor n.l. We don't care about the n.l. Remember that one of the nicest things now is that we don't care about the direction because these are microscopic particles floating, so don't care about the n.l. And here we have the pause, light position to pause, the distance, yes, because there's attenuation. We don't care about the n.l here, so that I can remove that part. The cosinus of the angle, yes, because we want to see if it's inside or not, so we can remove this part here, and we have here this light, and then we return this light. Let me be sure, vector 3 light, it's 0. We do all these computations. I hope I'm not missing any property here, any factor, anything that is not here inside. Well, anyway, it will crash. So, yeah, and I return it. Cool. So, way simpler. I can put here this compute light. And here I have to pass the position where I want to compute the amount of light, okay? And here the amount of light, it should be computed on the corner pose. And that's mostly it. I mean, I don't think I have to do anything else. I have to tweak now, and probably it's going to look, at first, I hope it compiles. And secondly, it's probably not going to look very good. But I want to see how far I can go. And also, sorry, I forgot. I put here the light, and this light has to I have to apply here this irradiance. Yeah, I'm going to put here irradiance, and I'm going to put here irradiance. So we have the amount of light on that pixel is 0, but we're going to add this irradiance multiplied by the amount of visible that is still left, and by the air step, because it doesn't shine as much because, I mean, the less density, the less the particles shine. And I keep adding, and yeah, I think that's it. I don't feel there's much more missing. Besides, I'm not sure I'm uploading every single thing, textures and everything, but it looks nice. Anyway, let's go. Without further ado, let's check how much it crashes now. Compiling, and now waiting. And it crashed, obviously. And it crashed because air density. Did they call it different? Uniform. Ah, whoa. Okay. Nobody of you was paying too much attention because I made a typo. Typo here. Load. Okay. So we have something. I don't know what it is, but oh, look at this. Oh, that's nice. This is the first. I mean, first try, and it looks nice. Okay, that looks quite cool. I don't know if you can see it well. It's very subtle, but I can increase the density. Oh, okay. So you can see it works. We have this darkness, and I can select now this object, move it around, and you can see how it has this volumetric fog behind. So it's better than what I was expecting. Okay. Cool. Now because it works on the first try, which is strange, maybe I want to make it with the directional line more than this one. But before that, I want to play around with the spotlight a little bit. So I'm going to make it more intensive so you can see it, the problems. Okay. So here you can see one of the problems I was saying. You can see the steps. I don't know if you can see it on Zoom, but there's a huge, horrible banding here. Okay, and this is because we can see all the steps that when we're moving forward. We're jumping, and these jumps, it's easy to be seen. Okay, and even though here that it's very close, I mean the wall is very close, and if it was farther away from the light, like I don't know, if I go here and put the camera way farther, like way farther, this literally looks worse. One second, I'm going to reduce intensity, so you can see that this thing looks horrible. Okay, so. And also, but it's nice that if I control the cone, you can see how it looks like. Okay, so I want to solve a little bit this banding, all these strange things that we see here. And the best solution to solve this problem is when I do ray marching, I'm not always in every pixel I'm going to go the same distance. Sorry, I'm not going to start in the same position. I'm not going to start in the camera eye. I'm going to try to start in a different position. Okay, and that's quite easy to do. Here, remember that when we start with array, we started on camera position. But what I'm going to do is I'm going to go to here, and I say, hey, I want to, once I know the step distance, I want to move forward a little bit, but this little bit is going to be different for every pixel. So I'm going to need a random value, and luckily for me, do I have a random value here? This one over here. So I'm going to call this function, and if I pass a value that is different every pixel, in this case the UV, is going to give me a different random value, and this function returns a float random, and I guess it's a value between 0 and 1. So I'm going to push, this is going to be a value between 0 and 1, I'm going to push the ray the distance between 0 and 1 of one step. That means, like, if I'm going to do like a lot of steps like this, and every single ray starts from here, I'm going to make every ray start in one position between this point and the first point, okay? Because this value rand is going to be between 0 and 1, and I'm going to multiply it by the distance, so that means it's going to be between here, and I'm going to multiply by the vector, okay? So now, not all the points will start from the same position, they're going to start from a slightly different position. And if I save now, and I go to my, here, and I press reload, 1, 2, 3, and it's not very visible. I was expecting that it was going to be more visible. 1 second to be sure. Maybe the random is also not very good for this case. I'm going to try something. I don't know if this is going to be better or worse. 1 second. No, it's more or less the same. But anyway, restart, current post is restart, and redir is going to be a little bit different. Okay, well, anyway, I was expecting I was going to look a little bit better, but so, okay. But it's strange. As I think that I'm clamping to 500. But anyway, I was expecting it was going to look a little bit better. Anyway, here, by the way, you see that everything is black, okay? And obviously everything is black because I'm rendering this as a screen space plane at the end here. I'm rendering it here, and here I don't apply any kind of blending or anything. So what I'm going to do now is I'm going to remove, I'm going to leave this in case I want it. But when I compute the final buffer, here, the illumination buffer, I apply the radiance, blah, 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 everything. I'm going to add on top of that the volumetric render, okay? If there is a volumetric, obviously, because maybe, I don't know, for any reasons there's no volumetric, okay? But when I apply this, I want to add it to the current buffer. So that means that I'm going to enable, and I'm going to use source alpha 1 minus source alpha, okay? So that means it's going to add the current thing on top, okay? And also I'm going to disable the def test in case there's def test enabled, because this doesn't make any sense. And after this, I want to always disable blending in case I miss something that goes afterwards, like the props, for instance. Okay, so I think that's it. Let's see how it looks when we apply the volumetric on top. Okay, I'm going to increase the intensity. And for, yeah, I have the show volumetric. Why I don't see anything? Let me reduce the density of the air, maybe? Okay, I'm doing, yes, I know. I'm silly. I'm storing the alpha on the alpha channel, but I totally forgot to add alpha channel to the texture. Pew. Without alpha, there's not much to store. Let's see now. I have to remove it from here. And that's it. So if I go to the entities spot and I increase this one intensity, you can see now the code. It's easy to see here the problem I was saying before, that you can see that the light is getting clamped to 1. I don't know if you can see it, but it's like it's increasing, and suddenly it just looks like it's not increasing anymore because it's reaching 1, which doesn't look very nice. Also, if I reduce intensity, but maybe I increase the air density. Yeah, that doesn't look right. Yes, and also I didn't clamp I always is good to clamp when you have the transparency value. I'm going to clamp it. I want to be sure that it's between 0 and 1. I don't think this is going to change anything, but just to be sure. So there's something strange, because if I control the density, if I increase the density, I would expect it gets darker, and it's happening the opposite side, which is strange, because if I increase the air density, the step this and this value is going to increase, and I'm going to extract more transparency, so this value is going to be closer to 0. Oh yes, and if it's closer to 0, it's less visible. Yeah. The fog is less visible. Yeah, and then this is wrong. It's the opposite. It should be the opposite, like this, I guess. Because if there is a lot of fog, it should be very dark. As you can see here, that because there is a lot of fog, it goes dark very fast because there's no light. Here I can put the ambient light if I want it. Like at least there's some ambient light here. And then I will say that the amount of light of every pixel here, the radiance, or it is here, it's the ambient light plus the light. But this is going to saturate a lot the rendering. It's going to be lots of ambient light. But anyway, let's try to see how it looks like. So when I upload everything, I'm going to upload also ambient light. I don't think it's going to look nice. Let's see. It crashed because ambient light is vector 3. Was already defined? Ah, yes, it was already defined. Oops. Where is it? Ambient light was already defined on top. Here is one. Where is it? Ah, no, it's defined inside lights. That's why I didn't understand where it was. Okay. So here, if I increase the ambient light, and if I increase the density, yeah, this looks more like what I was expecting. And if I increase the spotlight, now you can see we have this beautiful spot. And if we move it around, you can see that it has a beautiful shadow. Okay, so this is volumetric rendering. As I said before, one of the cool things is that if it takes a lot of resources, you don't need to compute it at the same resolution. So if I go here and I compute it to half the resolution, you will see that it looks perfect and it's hard to spot the difference. Although I think that this texture, when I created less resolution, it looked more pixelated, but because I have disabled the bilinear interpolation, when you read from them, I have to enable it. I don't know why I disabled them. So let's go volumetric disabled and put the density more dense and put the spotlight a little bit more intense, like here, and finally making the spot a little bit more brighter. Okay, there's something weird going on now. Half of the resolution, but the UV. Oh yeah, I know. This is a classical error. When I compute the rest, I'm using this, which doesn't make any sense. Yep. No, sorry, not this one. It has to be the volumetric FBO. Okay. If you compute the ERES of the whole screen, but not the ERES of the volumetric FBO, is using a wrong size, and because it uses the wrong size, it's going to have problems when it computes the UVs, and that was what's happening before. So now, yeah, now it's better. Let's go here and put more light, bluish, more density on the air. It's not so much. And I want to have the spot super bright. Yeah, so we have this. And you can see it's hard to spot the difference now. It's half of the resolution, not half, like it's 4 times faster. You can see there's an error here. I don't know if you can see it. This kind of strange artifacts because it's computing well, the values are not right values. So this could happen, and to fix this problem, you need to apply a better upsampling, not just taking the texture and just upscaling as I'm doing now. But at least this is way faster, and I can play around with this. Okay. And with the cone, make it smaller if we want to. And if we put an object here in the middle, as you can see here, I still think that the problem I did with the random is not working. I'm super annoyed because the random value is not working. I have a better random, I think, on the slides. Let me see if I put some slides about how to make it random value. No, I didn't put anything. Damn it. Then I'm going to use the random value from like this very famous YLSL random noise value. This is a famous GIS that everybody uses that contains different random functions, but more or less is the one I was using. Yeah, I think this is one. So what I can do if I want to have more random, yeah, I'm going to do a trick, which is pass the time. It's always good. Time. So I don't get time. And I also going to pass a random value. Rand is going to be random. So I'm going to at least have two values on the shader to play around to make every pixel look different. And then in this case, instead of using, as I was using this random ID, I can put here a vector 2 that I'm going to add here first. It's going to be the rand value I just sent. So this uniform float rand and this uniform time. And let's go with this random and time. I don't know. At least these two values are going to be always increasing. So every pixel shouldn't have the same noise now. Yeah, I mean, one option is to pass a texture with the noise. That's another option. I can do that also. You just fill a buffer with random values and you upload it. But I want to try with using just not textures. I think it's a little bit faster because you use textures. The buses are a little bit more clogged. So let's go here. But thank you for the suggestion. It's another option I can try. And now I don't see them now, the error. Maybe I'm going to move this one to see if it looks. Nah, it's there. I can see the noise. It's blinking a little bit like blah blah blah. But I shouldn't be seeing these lines. Let me. I'm pretty sure I'm doing something wrong here, because if the right there contains. Oh, the right. No, yes, the right there is multiplied. No, the right there is not multiplier. It's right offset. Damn it. Sorry, I forgot to multiply this by this. I was surprised it didn't look like. Now it looks more noise. Now it makes more sense. There's a lot of noise now. It looks horrible, but at least you don't see the banding. Okay, and this noise can be easily mitigated with some blur. So that's why I was trying to come up with. And that's it. We are inside. Okay, so cool. That was how to make volumetric. You can play around with this, multiple lights for this moonlight, everything, and you will see how it looks better. And you can pass all the lights to the shader, or like at least 3 or 4, and it will look super better. Okay. And also remember that I'm doing some stuff like here, this 1.0 minus transparency. I did it because it makes sense that you start with a lot of this is very transparent. I mean, yes, because this is wrong, because this is not how much transparent is the pixel. Transparency was how much transparent next step on the right march was going to be. But at the end, the amount of transparency is left is the one you see, and the left is 1 minus the amount of transparency here. Okay, this makes sense. But here, as I said, you have to play a lot with the values if you want to come up with something that looks nice. So next thing I want to do is decals. Okay. As I explained the other day, decals is a very interesting thing. It's very easy to code, and it improves the quality of the render. And it only works on the ferret. If you want to do it on forward, it's way more complicated. But I'm going to try to do it now so you can see it. So, how to do decals. For decals, I'm going to need a texture to apply the decal. I have a texture here, so give me 1 second. I'm going to copy the texture to the folder of the application. So here, textures, yeah, this texture. I'm going to copy it to here, yeah, textures. Okay, so I have this texture now. Let me show you. Okay, it's a graffiti, it has alpha, and I want to apply this graffiti to the scene, okay? So I want to be able to move it wherever I want to, and the graffiti is going to try to be applied to any object. So I'm going to need to have decals in my scene, and currently my scene doesn't have an entity for decals. So here I have an entity only for prefabs and for base entity and the light. But I left here the option that if you want to have a decal, there's already a type here. So you will have to create your class decal, and it could be a simple class that only contains the file name of the texture that you want to apply, and that's it, and the rest is from the entity because we're going to need. So I don't want to waste too much time doing decals now, so what could be the easiest way? I'm going to do it because otherwise it's going to take me more time to not doing it. So imagine I'm going to have my decal entity, for instance, and I don't need to have nothing like this: decal entity, decal entity, decal entity, decal, and not loading, nothing, test ray, nothing, nothing, nothing. Okay, and this is going to be the file name of the texture, and that's mostly it. When I create this decal thingy, but what I do need is the load function, this one here, because this is the ones we're going to use to load the property of from the JSON. So what I need here to load is the file name. So I'm going to read JSON string, and what I want to read is the file name, and by default is going to be file name. And this is going to go to the file name property of this one. And the opposite, when I want to write the JSON, I'm going to write file name. I think this is enough. Why is complaining? Ah, yes, sorry, I forgot to put the JSON here. In which JSON do you want to write it down? Okay, so now I have a decal entity. It only contains, as I said, the file name of the image that where you want to apply it. I don't know if I have to specify data slash something. Probably yes. And the only thing missing now is that when I create my application, I have to specify which entities do I support. So here I have the decal. And when I instantiate something on the editor, I won't be able to see it on the editor because on the editor I don't have an option to see it. So here I have for inspecting every one of them. So I can, no, not this one. This one here to see decal entity. So let's copy, I don't know, this one. Okay, so if in any moment somebody wants to inspect the decal, and the only thing I have to care is about the URL of the image. So yeah, this one should be. File name, and that's it. Entity file name. That's it. I mean, it's going to change it, and that's it. So everything I care. Okay. And the last thing, sorry, I forgot to put it, that this function has to be called from here. So we have a decal, and we want to specify this as a decal. Okay. So if everything goes well, now I have support for decals. The only thing is that those decals have not been rendered. Now it's just an strange object in my code. And when I'm doing the renderer here and the step scene, no, I was taking everything, prefabs and lights. I'm going to need another place to store all the decals. I'm going to put here another one called decals because I need to iterate through the decals. So I better have them separated in another object. So here, if I have something that's a decal, I store it here. Cool. So if in any moment I need to know how many decals and draw something about the decals, I have them here. So next step should be fairly easy. When I do render the ferret in my application, I have to render all the objects inside my scene. I have here rendered all the scene nodes in the buffers. So at the end of this step, I have everything drawn on my buffers. The only problem here is I will need to read from the def buffer, but these buffers have already binded the everything. So I need to do something kind of strange, which is to render the decals, I need to be able to render, to read from the def buffer. But because the gbuffers has the def buffer binded, it's not able to read it. So the only solution to this problem is if I copy or clone the def buffer before I do anything. So there's probably other solutions, but I always use this one, which is I need to have a clone of the def buffer. Okay, so when I create all the buffers and everything, I'm going to create also a clone of the def buffer. Okay, so when I create in the buffers, I don't know if I did it this way in my code. I don't remember doing it like this, but anyway. So I'm going to create a new texture. When you create a texture, this texture has to be of the type for making def buffers, and that's not easy. So I'm going to try to go. It's a texture, but it's not this format. Okay, when you create a texture directly, it's not HJBA because it's def texture. I don't know if I put it on the slides. Probably I put it on the slides. Here, I clone texture. I say new texture. Yeah, I can do it like this. I guess it's going to understand that it's a def texture. I'm not sure. I mean, if I try to copy this texture to another one, I don't know if it's going to understand that this texture doesn't have a size here specified, and I don't know if it's going to work. I don't want to do that. So 1 second, I'm going to take from the line that when you create a def texture, I can do it from here. When you create here an FBO, it's creating a def texture here, and this is the properties that you usually put here, which is not exactly right. It's def component and unsigned int. They say it's not unsigned int. It should be something different, but this works. Okay, so in creating a texture, it's def component because I want to start def. And that's mostly it. So now we have the texture. So that means that after have binded everything, I can do something like this. Go to the gbuffers. Okay. And I want here to go to the def texture. And I want to copy it to this other texture, like def clone. Okay. And this is internally is going to create an FBO, it's going to check if the format, blah, 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 and do all the things. Okay, so just because it's a function doesn't mean it's easy, because here you are creating a new FBO and it's not very fast, but at least it ensures you at the end that this texture here will contain this def texture. Okay, so now because I have this, I can bind the gbuffers again. Okay, and that means I can continue render here. So I enable the camera. I can continue render here whatever I want to inside the gbuffers. And if in any moment I need to read the def texture, I will read it from this one, never from this one, because otherwise I'm going to produce an error on OpenGL. Okay, cool. So now we have the def buffer and everything. The only thing I need to do is iterate through every decal. Okay, so imagine I have decals. So for every decal, obviously all this only makes sense if I have to do decals. If I don't have decals, avoid trying to do all this because this will be very silly. Okay, so now I can, for every decal, what do? I should render a box. Okay, so I don't know if I have a box mesh here. I know I have a sphere one. I'm going to create I have the sphere. I'm going to create also a cube or a box, however you want to call it. So the same thing. So I'm going to go here and create a cube of size. I'm not sure if 1,0 or half. I think it's 1,0. And here I'm going to upload to the GPU, so it's way faster when I have to Okay, so what I want to do now is I want to render this cube, but I want to render where every decal is. Okay, that means that first I'm going to need a shader, obviously. So okay, decal, because I'm going to render only one. So we enable this one. We need to pass all information about the camera position and all those things. So I don't know if I have, do I have the camera to shader? Yeah, always very handy to have this one. Camera to the shader. Okay, and all the parameters are on the shader. The only thing missing is the model. So I need to have a model matrix of this 1.644 of this decal, and remember that the decal, because it's an entity, it should have the root node, and the root node has the model, and the model is a decal. I don't think I need to do this. I can just take the model and upload it to the shader. So. And okay, so we have the more important things, which is where to render this object. Let's go now to the and yeah, sorry, I forgot. Also, I should be sending the texture of the cloned def buffers. So set texture. So it's the udef texture, and the texture is the cloned def texture. Def buffer. And in which one? I don't know. 4? Okay. I still missing the texture. It's okay. I know about that. I will do that later. But I need to control the parameters. So I'm going to disable for now def test, which is not right. I will have to put the def test later, but I want to disable everything when I work. And maybe I need to render the inside or the outside. I'm not sure. I'm going to render only one of the sides. So I'm going to go with cool face enabled. I want to render only one side of the cube. You will understand what I think I'm doing now. So now I'm rendering one cube for every decal, and I'm going to use its model, nothing else, okay? Something missing here is that we need the shader, and the shader is going to be similar to when we did, oops, don't start right here. We're going to need the basic, because we are going to render geometry. And do I have one that uses basic, like using geometry? Spherical Pro, but this doesn't reconstruct the position. The ferret light, but this is not reconstructing. Anyway, I'm going to go with here. Okay, I'm going to take this one. I want the part where I reconstruct the position, so that's why I was searching for one that has the reconstruction of the position already done, so I don't have to write it down. So I won't have any of these things, but I have depth texture. I will have another texture later, but for now, this is the only very important thing, and I need to reconstruct the position. So I need the inverse VP. I need this code. This is under the ferret light. Okay. And the part where I reconstruct the position. Yeah, this one over here. So decal here. Yeah, all this is out. I don't care about this. So, and nothing more like this. I need the erase and the UVP because I need to reconstruct the position, and I forgot to put it on the shader. So EVP and erase, these two parameters, I need them. So here also. And the texture, I don't know, I can take any texture, like here the G buffers would be good for the size because it's the same size as the G buffer, and the inverse, and the camera to shader, and the depth, very important. This one over here, and over here. And I think I have everything to reconstruct the position. So now I go here, take the depth, and then the discrete position, blah, blah, world position. I don't need albedo, extra, normal, anything like that. Okay, so I have wall position, okay? For now, because I don't want to. I want to go a little bit fast. I'm going to just put the depth. I'm going to put here red, so at least we can see something on the screen where I'm rendering this this box. And let's try now. I don't have the decal on my scene.json, so that means that it won't be visible now, but it's okay because I can create it from the editor if everything goes well. I haven't discovered a lot of errors on the editor over the course. I'm remaking all the framework for the next year, but there are tiny errors that when you try to create things, or maybe it's a little too complicated. Oh, it crashed because flag color. Because I declared flag color twice. Damn it. Okay. Nah, damn it. I don't want the volumetric now. But anyway. So, let's create a decal here. And I have decal here. It's very tiny. I'm going to make it bigger and bigger and bigger. So I have this box now. Okay. This is the decal. We have the problem that we are... why is that visible? Well, there is nothing on the set buffer. Wait, sorry, it rotated. But anyway, forget about that. You don't see this part. No, sorry, because I'm discarding when the depth is 1. I'm discarding the pixels. It makes sense because I want to paint the decal on the wall. So if there's no wall, there's nothing, no sense to render. But as you can see, I'm rendering now without any depth buffer. Okay, so it's rendering all everywhere. Oh, it's going super slow. I know what it is. Sorry. It was going super slow, and the reason why it was super slow was because decal size was growing and growing and growing, and it was growing because I forgot to reset it when I was adding things inside. Every time you add something, remember that if you are doing it every frame, you better have it empty, otherwise it's going to crash. Okay, so I'm going to go now with, instead of just disabling the buffer, I'm going to enable it. I want to read from the depth buffer of the G buffers, because remember the G buffers contain the depth buffer, but I don't want to modify it, so I'm going to always def mask false, because I don't want to modify anything of the buffer when I render a decal. I'm going to let it through afterwards. And more important than that, I want to say that I only care if the pixels are behind the cube. And to do that, that means I have to say that the GL_def function is only going to care if they are behind a wall. Yeah. Greater. Okay? So it's only going to render the cube, the areas where are inside the wall. But I want to render the inner parts of the cube, not the outer parts. So because I have the cool face, it's going to only render the outside of the cube. I want to do the opposite. So I'm going to say that the front face is going to be the opposite. This way. I think this is the way to do it. To say that render the inner face, not the outer face. I'm going to put it back. Okay, if I remember correctly, that means it's going to render the inner parts of the cube, not the outers, and it's going to take into account the depth buffer, but it's not going to modify it, and only going to render the pixels that are farther from the depth buffer. So also remember to put it back to less. And I think that's it, and no blending. So with all these flags tweaking up and down, what we managed to do is to be sure that when I put the decal next to a wall, only the pixels that are inside the wall are going to be visible. Okay, so let's see now. I should have put also the texture, because now I don't have to execute it again. But anyway, I hate this. I had to put the volumetric render false every time. So I'm going to disable this render volumetric false. Okay, and going back here, I'm going to add decal. I'm going to make it bigger. Oops. Go back again to here. I'm going to make it bigger and bigger. But you can see that it's here. There's something weird. It shouldn't be visible. Yes. It shouldn't be visible. That's weird. It shouldn't be visible because now it's not behind anything. And I say that only when it's behind something. It's only left test when it's the function if it's greater. Should the cube be visible? I'm not disabling it again. Nope. That's weird. Enable def test, def mask pulse. Learn from face. Ah, yes. Oh, damn it. Careful with this. When you do the copy to, it's modifying all these flags. So be careful when you do any copy to. It looks like it's more like a conceptual thing that you're copying some memory to another memory. But inside this function, all the flags are changing. Enable, disable, max, blah, blah, blah. So be careful because this function is not going to leave the state of the functions as it was before you call it. That means that if you call this function, all your parameters are changing. So call it always the first one so it doesn't mess with the other ones. And as I was saying, I need to have the texture. I'm going to pass a texture. So in this case, color texture, and I'm going to go, I need a texture here, okay? So where does this texture come from? Decal texture. I need to, from the decal. So here, I'm going to go to this decal, and this decal has, oh no, not here, because every decal will have a different one. So this has to go here. So GFX and texture, decal texture is going to be get, and it's going to come from, I mean, if there is not a texture, I will have to do something. So if decal file name size is equal to 0, there is no texture. So I don't know, take the white texture for now, because I want to have something. So, sorry, this get white texture. Otherwise, take the texture with that name. Yeah, I think this one should work. Yep. Although here probably I need to put it converted to constant string. Yeah. So we have here a texture. It could be white. It could be the texture from the editor that we have specified, and we pass it here as the number 5 as a U color texture. That means that if I go to my shader now, and I put here from sampler to the UDEF texture, I can read this texture from here. Okay, I'm going to need to do that on my shader now, because I want to read the texture so you can see it. And I have the image stored on the data folder, so that should make it easy to do. So going, we're 5 minutes to 6, so almost there. No crashes, good thing. We add the decal. It's not visible, it's very small. We make it bigger, we make it bigger, we make it bigger. And as I was saying before, I mean, you can see if it's outside of the floor, we don't see it. Only when it's touching the floor, we can see it. Okay, that's a good thing. But remember that the pixels that are closer to the camera, they won't be visible. So here, for instance, we can see it because the depth is farther, but here not. Okay, that is going to filter a lot of the pixel, which is nice. And what we want to do now is project a texture here. And the next thing is if I move here and I put it in any wall, anywhere, it's going to project it on that wall. Okay, so if I want to put it here or there. Okay, so I need 2 things. First, I need to have a UV to read from the texture. And I do have a texture here. Okay, so I can do here, say vector for color equals to texture this. But I need some UVs, okay? And to get UVs, I need to know this point here. If the image was here and it was projected in this axis here, I don't know, Z axis probably, what would be the X and the Y of that point? The problem is I need to convert from wall space, because this point I have the wall position, I need to convert it to decal space. And this decal space, remember, it goes from -1 to 1 in every single axis of the cube. So to convert from wall space to decal space, I will need the inverse of the model projection, which I forgot to put it. So that means we need another matrix. So let's go here and say I need the E model. Okay, so going to my shader, I'm uploading the model, but I'm going to need also upload the E model. And the E model is equal to the model, but I'm going to invert it. Okay, so now we have the model and the E model. And also I didn't enable the blending. I'm going to enable the blending because I want to also start doing something with the alpha. What the fuck? Where it go? It's cursor. Okay. And I'm going to use the blend function to make linear interpolation. So source alpha here, 1 minus source alpha. Okay, so that means that using the alpha, I can control how much I want to paint every pixel. Okay, I think that I don't need to do this kind of the function grader or not. Yeah, I need it because otherwise if I'm inside, I won't be able to see. Yeah, I need to do it. I mean, because if you're inside the cube, it won't be visible, but doing this trick of rendering the inside faces, not the outside, I can be inside the cube and it's still visible. Cool. So that's it. Go back again. Well, this, I can check this here. So I have a world position and I want to convert from world position to decal space, from 3D coordinates of every corner of the world to areas inside this cube, where the 0, 0 is in the center of the cube, -1 is on the sides of the cube, okay? Or -1, 1. So, and it crashed because I forgot to put the UVs here. Okay, sorry. UV equals, I don't know. There's already UV, decal UV. For now, I'm going to put this, which doesn't make any sense, but let's do this. I'm not using this color, so it doesn't matter. And it's not crashing now. Cool. So I can add my decal, put it here. Also, I should store this as scene, so I don't have to do this every time. So I'm going to try to store it now. I don't know if I can save it now. Save. I hope it works. It says it saved. So if I close the application and reload it again, will I see it? Yeah, cool. So I don't have to do it every time. Okay, so I need this wall position. I get to convert the decal space. So let's try to do a very simple thing, which is I go to the model, multiply it by the wall position. But remember, I need a fourth component. So let's go here, and I only care about decal space. Okay, so something like this. This will convert from decal to wall position to decal space. And I'm going to do is I'm going to render the pixels using this decal space color to see what it looks like. Just I'm curious about it, how it looks like. So yeah, I think it should look something interesting. So we have this, which is nice. You can see it makes sense. I mean, the right side is blue, the left side was negative blue, so you don't see it. Below it's negative green, and up is positive green. Okay, but when you use textures, I want to value from 0 to 1, not from -1 to 1. So always it's good to go if I'm going to take the decal space here and multiplier by 0.5 and add 0.5. And if you do this instead of going from -1 to 1, it goes from 0 to what? Nope. It goes from -1 to 1. Yeah, it should be. Why does it look so whitish? Maybe it's the tone mapper, maybe? Well, I have a tone mapper, and I'm worried that the tone mapper is modifying the color, so it's hard to see. Yeah, I was expecting something more like from a gradient from color to color. I'm not happy about how it looks like. Maybe I did something wrong. I will see now. So anyway, so I'll go for the decal, which is this one. And also I don't like this kind of strange, there's a strange thing here. I'm doing something wrong. 1 second. Well position, XYZ, here, and now decal space is equal to decal space to 5. Well, anyway, and if I take this decal space X and Y and use it as the coordinate here, X and Y, I don't know, let's see how it looks like. It looks exactly the same because I'm not using the color. So let's put here the color. Okay. Remember that this is the white texture, but if I go to here and I search for my image here on data, textures, this graffiti, it loaded. No, it doesn't. Oh, it didn't load the image and it crashed it. Oh, okay. Well, anyway, there was an error. It's a silly error. It's just that in my engine I forgot that I have to specify when you search for a texture. This is kind of ugly. I have to put here data slash, which is super ugly. This is solved in the new version, but I forgot to solve it in this one. That it always tries to search on the path, not the relative path. Okay, it's okay. That should work. Let's see. Okay. Go to the decal, choose the texture, graffiti. Okay, the texture is there. I'm using the wrong direction. So here we have the image, okay? And it's poorly aligned. Yeah, the size this doesn't go from 0 to 1. It goes from -0.5 to 0.5. So I think I did something wrong when I was modifying the texture coordinates. 1 second. I think I shouldn't be multiplying by 0.5. Let me see now. Yeah, this looks better. Okay, so you see, we have now a decal. And the nice thing about this decal, okay, it's very easy to manipulate. If I want to manipulate it, I go to the decal and I can move it wherever I want to, okay? And it aligns with the surface. You can see here we have a window, and it's perfectly aligned with this surface, okay? It's very shiny. Ah, yeah. It's very shiny, okay? You can see, like, it's if I'm painting the wall with this graffiti, why is so shiny? The problem here I have is that if I show the G buffers, it's drawing the same value to all the 3 G buffers, to the normal and to the emissive, and that's messing up everything. And the reason why it's doing that is because I'm only drawing render frac color. I'm not using for normal color, blah, blah, blah. So when you does the output of the, usually you have all these G buffers, sorry, this one over here. I should be rendering different values for every buffer, this one over here. Because I'm not doing that, I'm going to put here this. Now at least these 2 values, I'm not specifying anything. I know what will happen if I reload now. Okay, I reloaded, and still you can see that because I didn't specify any value on normal color, on extra color, on my shader, only the frac color, this one, it's still putting on every one of the other ones the value, okay? And I could just say, no, I don't want to put any other value here. So I can say, I don't know, the normal value and the extra color are 0. Like, for instance, here is for 0. But if I do this, yes, I'm killing the emissive, which is better. But this is wrong, because what I'm doing now is blocking the emissive. If there was emissive here, well, it makes sense, because if there was emissive here, you want to kill it. But I don't want to do it with the normal, because the problem if I do it with the normal, if I go here and say the same with the normal, like here, you won't see much different now, okay? But the problem now is I destroyed the normal buffer. And what? Oh, yes. No, what? That's interesting. Oh, it makes. Well, yes. Okay, I understand. Let me just try something. This is something I didn't know. Oh, that's cool. That's nice. Okay, sorry. Because the alpha is 0 now, when I put normal color, the alpha is 0. When I do the blending, it's going to do the blending independently for every one of them. I didn't know that. So it means that if it's going to do the blending here, and the alpha is 0, so the blending is not going to look anything. So if I store here and reload, it's not going to be visible. Here it's going to also do the blending with the emissive, and the emissive is 0, so it's not going to blend anything. And here, yes, it's going to blend with the alpha, right? Alpha that comes from the texture, so it's going to blend correctly the area. Okay, cool. And so we have a way now to put a decal on our scene. And this is not fixed because we have still this problem. Okay. Look, it looks weird if I look at from. I'm going to put more shine so you see it better. 1 second. So here you see this. Okay. What's going on here? The problem is that this point over here, if you convert it to decal space, it's still inside the. I mean, it's taking every single point that is behind the square now. Like if I go, I don't know, to the house here behind, maybe it's not visible because it's in the other direction. Yeah, but here, here, that's weird. I was expecting it was going to be visible. But anyway, if I take this car now and I put it here and I move it up, the problem is that this square, you can see the box because it's behind and it's converting the X and Y, and when it's rendered here. So you want that if the point is outside of the decal space, outside of the cube, don't render it. And the best way to do that is just by checking if the Z is inside or outside. So if I go here and I say if this decal space X is smaller than 1 minus 1, or this decal space X is bigger than 1, or, and I do this for every single axis, so here, sorry, yes, then I discard this pixel. This means that this pixel is outside of the box, okay? So if I do this now, you can see that now it doesn't apply, okay? So that's the way to filter pixels that outside. And that's it. We have a way to put decals on our scene. Oops, not this one over here. So you can make it bigger, and you can rotate them if you want to. Oops. You can, I don't know, you can play. Obviously here, because the cube is very big, it's also going to apply to all the others. But this is easy to fix because if you just go to the cube and you make it smaller, like smaller like this, at least you can counter, well, you can make it more adapted to some area. And you can see that even here, that when it goes inside the window, it looks good. And also, because this is regular gbuffers information, if you go now to the spotlight and you make it very shiny and you move it around, oops, I did what I did. Whoa. Sorry. The volumetric thing is messing around a little bit everything, but anyway, you can see here that you can easily illuminate areas with decals. The problem with the decals, the biggest problem usually is that if you have other objects, as I was saying, and you put it around the object is going to have the decal applied too. Okay, and that's bad. It's bad because here, if it's a static object, it's still, you can think that it's not so bad, but if you have a real character walking around, it's going to have this applied. That's easy to fix. You can have masks, as I was saying, and store which pixels should have decals or which not, and reading from the masks, there's the stencil mask that you can apply that allows you to filter some pixels. Okay, and that's it. That's everything I wanted to talk today. As you can see, it's easy to apply decals, and volumetric light is complex to make it more beautiful. Remember that for the decals, I will expect you that you use also the decals. You can have roughness and metalness, and you play around with that, and to make it like, I don't know, maybe you want to make the floor more shiny because you want to put a puddle of water, or you want to play with more interesting decals. That would be nice, that you showcase more possibilities for decals than the things I have done, because this is a basic one. Okay, that's it. Next week I'm going to talk about post-processing effects, and that will be everything. And if you have questions, we will see you Monday, but I recommend you to use the Discord. I also wanted to show you, now I have a little bit over time, but sorry, I want to show you the current state of, like, I put some screenshots today on the one second, on Discord. This is my version, the one where I put all the algorithms that we are discussing. You can see the same is the same. Okay, there's some minor differences. I have some algorithms that you don't have still, because I will explain next week. I don't have the reflection and I don't have PBR here, so don't worry about that. I was playing with different kinds of tone mappers. I put different ones here to see which ones look better, because there's a lot of different tone mappers. But what I wanted to show you is that it's nice when you try to bake the irradiance. So I have here this element on my scene called this new irradiance volume. It's the same I did today, but with irradiance volume. You can see all the spheres here. And nice things, I can move them around where I want to. I can also scale them if I want to. I can do scale them, or I can even rotate them if I want to. Okay, this is a feature that I didn't do for the other one. But if you just, I apply, by the way, I apply more or less the same approach I did now with the decal. I convert the decals to, sorry, the props to volume space using the inverse of the model, and that way it's easy to move around using the model instead of the start and the end as we were doing the other day. But I think nice thing here is like if I update them, you will see now. Take some time. It's computing done, and here we have the profs, okay, and I have here the factor to making them shinier. So if you see to see, so if I go here and make it shinier, you can see all this beautiful light from that it goes to this bluish trash can and bounces, and you can see here they look super nice. And also here I have this sign here, and it's all has all the thingies here, so it's the red neons goes to this part here. Okay, I'm going to remove these bolts here. So it's important when you do the irradiance that you can see the irradiance. It's easy to spot it and how it looks like. Here even I have a parameter to show the irradiance buffer, which is this one. Okay. So always when you do the irradiance, try to come up with something that looks like this. Like there's a lot of information about irradiance, because if you do the irradiance but it doesn't look, when you render only the irradiance, doesn't look realistic, or at least there's information, there's something wrong probably on your algorithm. Okay. That's it. Next week I will explain you the post-processing effects that you will be able to do something like this. 1 second, so you will see this kind of things where everything is more shiny, and this is an easy algorithm that makes everything look more interesting. And that's it. Thank you very much. Not many questions as always, which is always annoying, but anyway, see you on Monday. Bye.